I've shared my screen and important topic I'm going to start today. VPN, Virtual Private Network. VPN, Virtual Private Network. So in general, VPN means like any tunneling technology, any tunneling technology uh, that extends private networks over shared network infrastructure. Shared network infrastructure. But VPN, in general, I mean, like just VPN, no IPsec or MPLS or any other. So VPN means like not necessarily always encryption, because there are a lot of VPNs like wherein no encryption is done. So not necessarily always encryption. And if I take some examples like your even in layer 3, GRE tunnel itself is a VPN, generic routing encapsulation. IPsec tunnel, of course, is a VPN, IPsec VPN, layer 3 VPN. Even MPLS can be either layer 3 or layer 2, but MPLS VPN is also another VPN type. In layer 2, also like we have traditional or legacy like frame relay is VPN, L2TP, PPTP, or your what do you call it, VPLS even, any transport over MPLS, virtual private LAN service, even Metro Ethernet. So they all are basically VPN technologies. So VPN means like any tunneling technology that extends private networks over shared network infrastructure. Shared network infrastructure even can be internet also. So we can use internet as a transport. And if like layer 3 network is extended, then layer 3 VPN, layer 2, then of course layer 2 VPNs, like if we want like the same VLAN, for example, to be on remote site. So that's what like layer 2 VPNs are. So layer 3, layer 2 VPNs and any tunneling technology wherein like network is extended. So that's what VPN is. But in this FortiNet or in any firewall technology, whenever we study VPN, so always VPN here means like IPsec VPN or maybe SSL VPN only. IPsec or SSL VPN. Of course, we are not going to discuss here like MPLS or any other VPN, VPLS or MPLS or any other technology. However, they all are VPN. VPN is like encapsulation, encryption, only encapsulation. So that's what VPN is. Any tunneling technology, right? Further, if I just quickly take example, just a quick recap. So when we even create GRE tunnel in networking routing, generic routing encapsulation tunnel. So basically, what we do, if there are let's say 3 routers, R1, R2, R3, network connected here is 10.0.0.0/8, and network connected with R3 is 30.0.0.0/8, right? Uh, Objective is like to extend network like 10.0.0.0 means like to ensure communication between 10 network and 30 network, right? So they should communicate with each other. But router in the middle, R2, let us assume, doesn't have route for 10 or 30 network. R2 has route for only directly connected networks. For example, here if I take 1.1.1, 1.1.2, 2.2.2.1, and 2.2.2. So in R2 routing table, like by default, like there will be route for 1.1.10 network and also 2. 2.2.0 network, because they both are directly connected networks, right? But R2 doesn't have route for 10 and 30. Let us assume even we cannot create, like we cannot put any route like in R2 routing table. R1, R3, even if we create a static route, or maybe we enable or configure any routing protocol, R1 and R3, but still communication wouldn't be possible, because even if I put any route here in R1, that in order to route 30 network, your next hop would be 1.1.1.2. So even if I put route here in R1 routing table, so still routing wouldn't be successful. Why? Because routing is always hop by hop, and if a computer here, maybe this guy, and there is another machine, IP address, if I take, let's say 10.0.0.5 is the IP, destination IP, 30.0.0.5. So 10.0.0.5 like wants to communicate with 30.0.0.5, right? So packet sent to the gateway like R1, sourcing with 10.0.0.5, destination is 30.0.0.5, and R1 does have route for 30 network with next to 1.1.2. That means this packet is now sent to R2, sourcing with 10 and destination is 30. And if we look at packet, so in case just packet, not the frame, that means IP header, and in case of ping, it is ICMP, of course. And IP header means like 10.0.0.5 and 30.0.0.5. So now R2 will look at the routing table that do I have route for 30 network? No, there's no route for 30 network. That means either packet is silently dropped by R2 or R2 will send ICMP unreachable message back to the R1 that network is unreachable, right? So unreachable message is sent back to R1, or just silently packet can be dropped here, no routing at all. So what we do, like to overcome, to address this problem in networking, and the simplest method is just creating a GRE tunnel. If we create GRE tunnel between R1 and R2, and GRE is basically a VPN tunnel, basically layer 3 VPN tunnel. So if I create a GRE tunnel between R1 and R3, then is this problem can be addressed, problem can be solved. And how does that happen? So let me quickly take a different color here. So if I create a GRE tunnel between R1 and R3, it's a GRE tunnel, generic routing encapsulation tunnel. So just creating GRE tunnel will not solve the problem, but once GRE tunnel is created, right, between R1 and R3, then we would have to modify a routing table also. In case of a static route, now this next hop address would be tunnel interface IP address. So what we do, we just assign any IP address, let's say 13.0.0.1 here, 13.0.0.3 tunnel interface IP, and also internal interface IP, we also specify tunnel source and tunnel destination address. So if I think R1 here, so for R1 tunnel source is of course 1.1.1 and tunnel destination is 2.2.2, right? Tunnel source is 1.1.1 and tunnel destination is 222. For R3 tunnel source are 222, tunnel source destination 1.1.1. And tunnel interface IP is 13.0.0.1 here, and maybe 13.0.0.3 or 13.0.0.2. There's only two IPs. So now, and in routing, let's say we are going to create a static route. So in this routing table, static route, next hop address now, next hop address will be tunnel interface IP, that is 13.0.0.2. Or simply, you can say like exit interface will be like this tunnel interface. And now problem is solved. It's a VPN technology, right? We have created a VPN tunnel between R1 and R3. Because what happens when we create GRE tunnel, then packet is encapsulated inside GRE. Extra layer is added, extra header is added, and headers rather, I would say, because GRE header and IP header, two extra headers are added to the original packet, right? That means now this packet is further encapsulated, tunneled, and that's what tunneling is. Now this packet is tunneled, right? And tunnel means two extra headers are added, a new IP header, GRE header, and original IP header and original packet, or maybe ICMP. So extra headers, two extra headers are added to the original packet. So it's a tunneling, right? Packet is tunneled. Tunnel means put inside this GRE tunnel and problem is resolved. And this is your original packet, right? So now what happens? R2 in the middle. Well, look at IP header, a outermost IP header, right? Outermost IP header, and in outermost IP header, source IP address means tunnel source IP, that is 1.1, and destination is tunnel destination IP address 222. So now what happens? R2 will look at the routing table. Do I have route for 222? Yes, 222 is directly connected. And now this packet is successfully routed to R3. When reply packet comes back, reply packet means sourcing with 222, tunnel source, destination 111. Again, R2 has route for 111. Then again, packet is successfully routed to R1. And this way, without doing anything on R2, without modifying routing table, successfully we have routed a packet like between two different networks, 10 and 30, with the help of GRE tunnel. So now this GRE tunnel is basically a layer 3 VPN. So tunnel means encapsulation. In this case, only encapsulation. Why only encapsulation? Because data is not encrypted by default, right? Only encapsulation. Encapsulation means adding extra header to the original packet. Further, if required in some other technologies, what we do, we also protect this tunnel. This GRE tunnel even can be protected with IPsec, right? And what do I mean by like protecting GRE with IPsec or any tunnel with IPsec means now further encrypting data payload and maybe adding some extra headers to the original packet, right? Some new header, in fact, like ESP header. So that's what like your encryption is. Encryption means further like encrypting, converting plain text to ciphertext, right? Plain text to ciphertext. So this GRE tunnel can further be protected with IPsec. So it's a tunnel, secure tunnel now, secure tunnel. But at high level, understanding of VPN is something like any tunneling technology, just VPN, right? No, I'm not using term IPsec VPN, only VPN. So VPN means tunneling technology that extends private network over shared network infrastructure, right? But if uh, like data is also encrypted, there is encryption also along with the encapsulation, right? Like IPsec or SSL. Then specifically we use the term IPsec VPN, SSL VPN, right? And then further, like there are some other technologies also, wherein like MPLS VPN or GRE tunnel. Frame relay itself is a VPN because packets are encapsulated inside frame relay, right? Extra layer is added, DLCI number. In Metro Ethernet also like RQ-in-Q tunneling. Packet is encapsulated in and extra layer 2 header is added basically. So that's what VPN is basically. So in one line, like we can define. But now, what about IPsec VPN? Because our objective is to understand IPsec VPN or SSL VPN. Because from security angle, security perspective, like we, because in this IPsec or maybe SSL, also like we also use two other terms here: side to side VPN, side to side VPN. Just a second. This need to be refreshed. If internet flash for a while, then this basically works online, Microsoft Whiteboard. So it's getting refreshed. In the meantime, let me use this desktop. So as I mentioned, like IPsec, VPN, SSL VPN, and also from implementation type, we have site to site VPN and remote access VPN. Remote access VPN, right? So IPsec and SSL means like using different technology uh, for key computation, right? For key computation, because in IPsec VPN, because we understand VPN is tunneling technology. When you use IPsec tunnel, so it's about like both tunneling and means encapsulation and encryption both, right? Secure VPN, secure tunnel means encapsulation is done. That's true, but also now encryption is also done. Secure tunnel. And why encryption is required? Because in IPsec VPN or SSL VPN, generally we use internet as the transport. So transport here is internet. So transport that we use is internet, right? Not any private cloud. I mean, like no MPLS cloud or Metro Ethernet cloud. Public network. We use public network because internet is public network. Private cloud is something different. Our private network could be like MPLS or some maybe Metro Ethernet or frame relay or any other like technology. So internet, as we all know, is public network, like million billion of like users, computers connected to the internet every time. So if we are using internet as the transport, so we cannot have only encapsulation in place, right? Because if data is only encapsulated, further not encrypted, so it's a big security risk. We cannot send data in clear text using internet as a transport, right? And that's the reason like we use like encryption, data integrity, and a lot of like other terminologies in VPN, right? So now it's refresh. Okay. So that's the reason like we use different terminologies because of this what to call it. Okay. So because we are using internet as the transport, internet. So if internet is the transport and two networks here, so even if we set up IPsec tunnel, sorry, just VPN tunnel, let us assume any tunnel, right, between both devices, network devices, router or firewalls, and no encryption, this tunnel is not secure, not protected with IPsec. So yes, a big security risk because like if data is sent in clear text, only extra layers or headers are added just to solve routing issue, right? But data is still in plain text. So yes, it's a big security risk. And that's why uh, this data, or maybe including some header also, is encapsulated, converted to ciphertext from plain text, right? And here there comes another big challenge. And big challenge is about key, how like this data is encrypted. What is the key for data encryption, right? Because if R1 has like different key for the encryption and R2 has different key, so decryption couldn't be possible, right? There has to be same key, right? Means same key used for encryption and decryption. Really, this would be fast. In fact, technically, we use a term symmetric encryption. Symmetric, because asymmetric means using different key for encryption and decryption, like private and public key combination, private plus public key. So if we use private and public key combination, So that's what a symmetric encryption is. So symmetric means using same key for encryption and decryption. But how that would be possible? Like there are two routers, one router maybe in India, another router maybe in US East region, US West region. So how they both would have like same key, in fact, right? Whether key will be transported via internet, or how like they both would have same key. That's a big challenge, and I'm going to explain that also. But yes, in IPsec VPN, data is encrypted, symmetric encryption is used. Same key is used for data encryption and decryption, right? And the framework that we use is IPsec. So IPsec itself is not any protocol. We can say like IPsec is framework, Internet Engineering Task Force framework, ITF framework that ensure data confidentiality, data integrity, anti-replay mechanism, data origin authentication, means complete security, in fact, right? So IPsec is just a framework like to provide like security or secure communication between different sites. That's what IPsec is. But we also use SSL sometimes, like SSL VPN, right? So as I said before, in VPN, if we are going to use IPsec VPN or VPN to connect different sites known as site-to-site VPN. For example, if I have a headquarter and then maybe two branches here and one HQ. So HQ branch one means site one, site two. Objective is to connect all three locations, maybe in either full mesh topology or hub and spoke, right? That we have to decide. So if like tunnel is created between like routers, maybe if full mesh means like they also have like tunnel created directly with each other. There is no hub and spoke full mesh, or maybe hub and spoke, right? So here in this side-to-side VPN technology, we do not have choice. We don't have choice. We always use, or we would have to use IPsec framework for security purpose, right? For data encryption, data integrity. So IPsec is the only option. And that's why we use the term IPsec VPN or IPsec site-to-site VPN. So different sites and using internet as the transport to connect different sites, different locations. Network to network connectivity is about network to network connectivity, not like end user or mobile user. So for that, we use the term site to site VPN, or like sometime IPsec VPN or IPsec site to site VPN. One of the same thing, right? But another implementation of VPN is like remote access. So first implementation here, site to site VPN, and it's always IPsec. So framework is used, and IPsec is framework. Some people call it protocol, but basically it's a framework. So in site-to-site VPN, we do not have choice. Only IPsec is used. And site-to-site, I hope you all understand, like connecting different sites, different locations, different networks, branches to headquarter to branches, branches to branches. And then another VPN we have is remote access VPN. So let's first understand what is remote access VPN. So remote access VPN is like my corporate network here, any VPN gateway, any vendor device, and is my corporate network, internet, and mobile users, right? Work from home or laptop users, different cities, different countries, and securely they want to access infrastructure or resources of corporate network, enterprise network, but securely, right? Secure access to resources of enterprise or corporate network. Here, like servers, database, application. and remote users, right? So objective is to provide secure communication to corporate network, enterprise network, to mobile users. So this type of VPN implementation is known as remote access VPN. But in remote access VPN, we have like choice basically whether to use IPsec or SSL at first place, right? IPsec VPN or SSL VPN in remote access. And also clientless VPN or client-based VPN. So let's first understand clientless and client-based. So clientless means no agent software or client software is required to be installed on laptop or desktop or mobile computers, right? No extra agent or software is required. Clientless, no client software is required, right? Whereas in client-based, a client software, agent software is required to be installed. Even on my laptop, even I have like even FortiGate client software installed on my laptop. Here it is, open FortiGate Cloud. Also, I have Palo Alto agent. This one, not this one. Palo Alto also not connected or maybe probably disabled. And also I have Checkpoint client installed, VPN client installed. Because like I teach all three technologies. I teach like Palo Alto, Checkpoint, and FortiGate nowadays, right? And also I used to teach Cisco, also Cisco VPNs, but for last 4 or 5 years, like I believe I've not taken any batch of Cisco security. I mean, because Cisco is not very popular nowadays in security. But I've installed like client software. So if there is client software installed on your laptop or desktop, so that is client-based. In client-based, like we have like more options, and very much like in client-based, we can assume as if remote user is sitting in the corporate network, not doing like access from remotely, because IP address from a separate pool is assigned, internal kernel routing is done. So very much like accessing servers, computers, as we would have been accessing from the same network, in fact, right? So in spite of being like at remote side, we would have like same access experience, in fact, in client base. But drawback is what? A software agent is required to be installed on remote computer, a laptop user. Client based means a client software, VPN client. Also, we use the term agent. And different vendors have different client software. Cisco has like AnyConnect, or Checkpoint has secure remote access, or in Palo Alto, we have PAN, GP, Fortinet, we have Forti client software, right? So different like softwares, but software is required to be installed in client base. And you understand, like in order to install any software, administrative level privilege will also be required, right? So without admin privilege, even software cannot be installed. Whereas in clientless, no software is required, no client software, nothing. Clientless, just we can use any browser to access resources, right? But in clientless, there are a lot of limitations, in fact. This is something like we can publish uh, shared resources or accessible resources in portal or SSL portal, and we can use browser to access those resources. So with clientless, you would not have like same feeling that like if you are working here, like I mean, like you are physically in the same corporate network. No, very limited access. And generally, clientless is recommended for like maybe consultant or uh, partners, but for temporary access, right? Limited access. So in remote access only, we prefer client-based. Client-based means accessing corporate network resources with VPN client software. Now, even in this client-based also, if we want to use IPsec, then yes, we can use IPsec. And if we want to use SSL, then we can use SSL, right? We have choice between IPsec and SSL. So SSL and IPsec, they both are different, because SSL means secure socket layer, and IPsec, as I said before, like a framework. In SSL, your standard HTTPS protocol is used, like TCP port 443, no special protocol or software. Security-wise, they both are secure, but the way how keys computed or generated different. Protocol, yes, different, because in SSL, like it's just standard TCP 443. Mostly when we refer to remote access VPN, then mostly we use SSL VPN, but that's not true. Even remote access VPN can be IPsec also in client-based, right? But why do we prefer SSL protocol in remote access client-based? Because in case of IPsec VPN, right? In case of IPsec VPN, and let me get color blue. Okay, in IPsec VPN, I protocol is used, and I uses UDP port 500. ESP is another protocol. It's not TCP or UDP based. It's just its own mechanism. Protocol number 50. There is another technology here, NAT-T. If we use that, then UDP port 4500 generally is used. Right, in IPsec, right? Different protocols. Now, if VPN client or remote user is maybe like sitting at maybe airport or in hotel or any public place, there is public internet connection available, right? And if these communication ports are not allowed, so there is no way to connect to corporate VPN gateway using IPsec, right? Because in order to use IPsec, these communication protocol should not be blocked. And since we are using public internet, for example, or maybe internet service provided by airport authorities or hotel or maybe coffee shop, right? So you're not sure like whether these protocols are allowed with that like Wi-Fi router or maybe firewall or not. So there is always risk like whether we would be able to set up VPN, remote access IPsec VPN or not. So what generally we prefer? We prefer to use SSL instead of IPsec. So instead of IPsec, if we use SSL, so there is 100% surety that SSL will be allowed, because SSL means no special port. It's only about HTTPS. So if there is internet, definitely HTTPS will be allowed, because 80 to 90% nowadays applications are HTTPS based. There is no risk here, right? You don't have to ask anyone like, can they allow a permit like these ports? So it's one of the reason, not the security, in fact, why like in remote access VPN, generally SSL is preferred over IPsec. But technically, we can use IPsec also, right? Not only SSL in client-based. So it's a bit confusing, right? Remote access VPN side, because remote access VPN means like client-less or client-based. Further, in client base can be IPsec or SSL. Whereas in site-to-site VPN, it's always IPsec. It's always IPsec, right? So now let's start with this IPsec site-to-site VPN further. Now in IPsec site-to-site VPN, IPsec site-to-site VPN and site-to-site VPN. Now you understand, like connecting different locations, different sites, and IPsec is a framework. And IPsec framework means data encryption to ensure that data is confidential, data integrity check to ensure like data is not tampered during transit, during transport, and third, anti-replay means duplicate packets are not sent, and the fourth in data origin authentication. So IPsec framework means data encryption, data integrity, anti-replay, and data origin authentication. And now for data encryption, which algorithm, which method is used, that is decided by the security engineer. Means we have DES, digital encryption standard, triple DES, advanced encryption standard 128-bit, advanced encryption standard 256 bits, and so on. Data integrity, again, like we have SHA-1, secure hashing algorithm 1, SHA-256, MD5, and so on. Anti-replay here, like there is one like attribute of your protocol ESP, and yes, I'm going to explain it. What is ESP? What is sequence number? But with the help of this sequence number of ESP header, anti-replay is ensured. And data origin authentication is again like is part of very much your IPsec negotiation, like phase 1 and phase 2 negotiation, and I'll explain that also. But all four, data encryption, data integrity, anti-replay, and data origin authentication, are like part of IPsec framework. So if there is IPsec site-to-site VPN, then we can be sure that yes, data is not sent in clear text, data is sent in encrypted ciphertext. Data integrity ensure that data is not tampered during transport. Data has been reached intact, unchanged, no modification done, right? And anti-replay is like something sending the same data packet, maybe with some modification to the same recipient or destination. But how that is done? So for that, like we would have to understand ESP protocol, encapsulating security payload, and data origin authentication is another internal like check, in fact, just to ensure that data is coming from authentic source, in fact, right? Recognized source, not from anywhere. That's what IPsec framework is. And framework is like our IPsec is basically ITF standard. ITF means like your Internet Engineering Task Force. So IPsec is basically IETF standard framework, IPsec. Okay, now before I jump to this ESP and other like technologies, let's first understand why like encryption, integrity, anti-replay. I mean, like so many things. In fact, why not only encryption? Because what we understand generally, if data is sent in ciphertext, that means there is security, right? So if internet cloud and a sender means VPN client and our server connected with internet. So what we understand, if data is sent in ciphertext, means encrypted, all encrypted. So there is full security. No, that's not correct, right? Encryption alone cannot provide complete security, because if client machine, here is server, sends encrypted data, ciphertext data, right, to the server, still there is security risk. And how? So let me like this, like this. So basically, whenever data is sent, so outermost header like are not encrypted, but internal like packet, original packet, maybe original IP header. If in case of TCP, then TCP data all encrypted, and then some other like trailer and authentication. These are something like we can understand later on. But original packet is this. This is your original packet, IP header, TCP header data, and extra headers are added, and also trailer. So basically, this portion up to this is all encrypted, right? Means like ciphertext. Outermost IP header or maybe ESP header not encrypted. Outermost IP header means like source address, tunnel source, public IP generally, destination, tunnel destination, public IP, apart from other attributes. Now let us assume there is man in middle, means like attacker or hacker also connected to internet, and with some tool or somehow like maybe just hacking to this physical infrastructure, or maybe just because of any means, if this data packet is captured, right, taken by this attacker, hacker, right, and if attacker or hacker tries to see like what is inside it, can I make any change? Can I do something with the data? This portion, not possible at all, right? It's all encrypted. And in order to decrypt, there should be decryption key. So man in middle, yes, no key in fact for decryption. And if I take example of, let's say this is a very sensitive data, and if I take any example, like let's say this is your, what do you call it, bank server, maybe banking server, and the client, if I replace with any ATM, right, from where we can deposit money, and let's say a user or any like customer has deposited maybe 500 USD. So 500 USD amount is written here in data, that 500 USD deposited in this account, right? And the same guy, in fact, is trying to make it 5,000 USD, right? 5,000 means 500 means 5,000, just to tweak server, because both are like connected with some secure or insecure media transport, right? And we assume like there is no private lease circuit, is like something using internet or maybe a VPN technology. So if data or this packet is like captured here, so again the problem here is this portion, apart from IP header and ESP header, rest is encrypted, right? Encrypted. So even if somehow like packet is captured, uh, but problem here is this 500 USD is written here like inside the data payload, and 5,000 cannot be made like 500 cannot be made 5,000 USD, right? Because in order to do that, in order to edit the amount or change the amount, this data payload need to be decrypted because it's in ciphertext and there is no decryption key. Encryption and decryption keys are held by both parties, source and destination, right? So yes, no harm in fact, right? It's secure, but not. Why? If data cannot be decrypted, we understand that being like ciphertext, what if like this like attacker makes multiple copies of the same data? One copy, another copy, another copy, like replicated, multiple copies are created, right? And then multiple copies are sent to the same destination. So for a while, data captured, and then data is sent to the same server, multiple copies, maybe 5 copies, right? 5 copies. Now, the server may assume that 500 USD deposited 5 times, resulting to like 2500 USD, right? It's a hack into the system. 5 copies are sent, duplicate copies. And that's the reason like there should be a mechanism to avoid this type of like hack, in fact, right? Means sending same packet again and again. So in IPsec, there is anti-replay. Anti-replay. What is anti-replay? Anti-replay means if any packet reaches target destination, so what happens? Target VPN gateway will open this ESP header. As I said before, external or outermost IP header, ESP header, both are in plain text, and then further data is encrypted. And in ESP header, there is a sequence number of 32 bits. So when data initially sent, then inside ESP's header, a sequence number is embedded, inserted, maybe sequence number 4, 5, 1, 2, 3 or something. Basically, it is in hexadecimal. When we open ESP header, we see sequence number, or maybe with some command, then generally we find some hexadecimal number in 32 bits, right? Critically, when we try to see that. So just keep it, I want to keep it simple. So let's take 1. So let's say sequence number is 1, right? Sent here. What like attacker did? Attacker created multiple copies, replicas of the same, 5 copies maybe, and all 5 copies would have same sequence number. Sequence number 1, sequence number 1, sequence number 1, sequence number 1, and sequence number 1. Target means like remote VPN gateway, remote peer gateway can identify easily that except first, all other packets are duplicate packets. Same packet has been sent, replayed, right? And that's what anti-replay is. Means denied, discarded, right? Why? Because they all have same sequence number. And sequence number is one of the important attribute of ESP header. ESP, encapsulating security payload, right? Now, next question. If ESP header, and as I said before, ESP header and outermost IP header, both are in plain text, And if hacker or attacker is so intelligent that can capture packet, can create multiple copies with help of some tool or automation or scripting. So why not like changing sequence number of each replicas? Yes, because ESP is at least in clear text, decryption key not required, ESP is in clear text, IP is in clear text. So why not changing or modifying sequence number, right? First copy, sequence number 1, and then second copy, sequence number 2, third copy, sequence number 3. So this way, anti-replay mechanism will be failed now, because remote or VPN peer gateway will see different sequence number in different packets, right? And can be done because ESP header is in plain text, clear text, no encryption. Here comes data integrity check. Now what happens next now? Target VPN gateway, peer VPN gateway will run hashing algorithm like message digest 5 or SHA-1 or maybe SHA-256. And this encryption is done by using AES or something, right? So nobody hashing algorithm. Hashing algorithm is a mathematical computation to check whether data has been changed or tampered during transport or not. How it is done? So basically, sender like performs mathematical computation like MD5 or SHA-1 hashing algorithm, and whatever result comes after running hashing algorithm is embedded, right? Here, like in this trailer side of the packet, like ESP trailer, and sent across on destination, reaching to the VPN remote peer gateway. Same mathematical computation is done, and if I assume that hashing algorithm, like here result was like 4A023B something. Now hashing algorithm is again done here, like computed, and if hash value differs, let's say now computed value is like 3 something, not matching with the original hash value, so immediately identified that data must have been tampered, changed during transport, right? And will that happen? Yes. Why? Because hashing algorithm, when hashing algorithm is run, then ESP header is also included with one or two exception. One or two attribute of ESP header is exempted. For example, TTL value. Not this, sorry, not in ESP. Like when we use basically AH, then that is required because IP header is also included. But in ESP, even no need of that, right? Because in ESP, encapsulating security payload, this outermost IP header is already excluded, so no worries with that, right? But in there is basically another protocol, AH, similar to ESP. So in AH, in fact, this complete data payload is like checked for any change. So there, like some attributes are exempted because outermost IP header means like there will be decrement of TTL on each hop. So automatically, like TTL value may get changed, maybe DSCP marking or something. So in AS, like there are some mechanism, internal mechanism to exclude some of the attributes because that is bound to happen because IP header means like some of the attributes will be changed during transport. But in ESP, there is no problem with that also because in ESP, outermost IP header is not taken in hashing computation, right? Only ESP header is taken, so no problem with that, right? Okay, so ESP header is included in hashing algorithm, and if man in middle or hacker or attacker created multiple copies, changed sequence number. So sequence number is one of the attribute of ESP header. Means ESP header attribute or value changed now, and this would result in different hash value. This way, even technique or tactics creating multiple copies, also changing sequence number cannot be used. And the last, why not then also manipulating with the hash value? Because hash value is computed by the source and then hash value of this MD5 value is embedded somewhere in the packet here. So if hacker is so intelligent, so why not he also changes this hash value, because recipient is comparing computed hash value with the hash value embedded in the packet, right? Would that be possible? No. Why? Because this portion is also encrypted. So in order to see like the hash value embedded, there should be decryption key, right? That is also not possible. Means if we comply to IPsec framework, that is encryption and data integrity or anti-replay, then yes, there is complete security. If I say, okay, data is sent in ciphertext, 100% security, definitely I would be wrong. Because encryption alone cannot provide complete security. So at least now you understand why in IPsec, like we use like IPsec framework, we talk about encryption, data integrity, data origin authentication, anti-replay, because encryption alone cannot provide complete security, because internet, we understand, is public transport. So we cannot afford to take any security risk, even though like it's mandatory configuration. So we do not have choice when we configure IPsec. So it's like mandatory configuration. We would have to configure with encryption algorithm, hashing algorithm, right? Everything, ESP or AH protocol. 99% we use ESP, encapsulating security payload. So I hope this point is also clear to all of you. Like in IPsec VPN, why like we always talk about the framework, encryption, integrity, because encryption alone cannot provide security. Encryption alone cannot provide complete security. Next point, like I would like to explain here is, and that's very important too. Whenever we configure IPsec VPN, IPsec site to site VPN, so there are two different ways to configure VPN in most of the vendor. One is policy-based VPN, and the next one is route-based VPN. Route-based VPN. There are two different ways to configure site-to-site VPN. Policy-based VPN is nowadays known as legacy configuration method, and route-based is like the modern way of configuring VPN. But what is the difference between policy and route-based VPN? That's also very important to understand. And configuration-wise, if quickly I just take the example of Cisco routers, so probably you can easily then understand. So when we create IPsec tunnel in Cisco router, for example, if I take example of Cisco router, iOS-based router, internet is the transport. So in Cisco router also there are two different ways to set up or configure IPsec. One method is like creating a tunnel interface, like your VTI, virtual tunnel interface, then protecting this tunnel interface with IPsec, creating route also. This is one way to configure IPsec VPN. Means a tunnel is created here, and then tunnel is protected with IPsec. IPsec is used to protect the tunnel, and then we put route here. Like in R1 also we put the route that in order to reach 20 network, your next hop IP or exit interface should be tunnel interface. So what happens, and this type of configuration is basically route-based VPN. Route. So what happens basically now, let's say any packet like from this LAN network side hits the router like R1 interface. R1 immediately check the routing table. Do I have route for 20 network? 20 is the destination network, for example. And if R1 finds a route in the routing table that yes, I have route for 20 network, and how I'll have to route via tunnel interface. So packet is put inside this tunnel, and tunnel is protected with IPsec. So there is complete security that a tunnel is protected with IPsec, right? So this way, like decided whether packet has to be put inside tunnel or has to be sent in clear text directly to the internet. So decision is taken on the basis of routing table lookup, right? So that's what route-based VPN is. Route-based VPN means whether traffic will be sent in clear text, ciphertext, internal, and without tunnel. Decision is taken after performing routing table lookup. It's a modern way of configuring VPN. Route-based VPN means creating tunnel, then protecting tunnel with IPsec. In legacy or old ASA firewalls, route-based VPN was not supported at all, right? ASA firewalls, adaptive security appliance, old Cisco firewalls, route because basically in Cisco ASA firewalls, we cannot create tunnel interface, we cannot create loopback interface, we cannot run BGP even. A lot of limitations, right? A lot of limitations. No tunnel interface. Even in routing, also like we cannot create two route to the same destination with the same AD value. Like doing ECMP kind of thing also not supported. So a lot of routing functionalities are features missing, right? So in legacy old Cisco firewalls, route-based VPN even was not supported, right? Only policy-based VPN. But nowadays, and even Cisco routers support both. We have choice. Either we can configure VPN in this modern way, like route-based VPN, or maybe the traditional or legacy way, policy-based VPN. We do have choice. But the question here is it only about the configuration, commands, steps, or is there any technical difference? I'll come to that point also, but let me explain policy-based VPN also. And what happens in policy-based VPN? In policy-based VPN, basically, decision whether like packets will be sent in clear text or encrypted is taken after matching packet with policy or ACL. So what we do in policy-based VPN, we create ACL, access control list, for interesting traffic. If there's someone from 10 network wants to communicate or send packet to 20 network, then packets should be encrypted, right? So what happens now? R1 first match the packet with ACL. What do I have to do? Like, do I have to encrypt the packet or not? If that packet matches ACL, there is perfect match, then yes, encryption would be done. No match, encryption would not be done. That means decision is taken on the basis of access control list, or in other firewalls, we use the term policy. We create policy, source and destination, then encrypt or do not encrypt. That's the way how policy-based VPN is configured. So in IPsec site-to-site VPN, there are two different methods, there are two different ways to configure VPN, either policy-based VPN or route-based VPN. In Cisco router, Cisco IPS-based router, both are supported, right? In ASA firewall, only policy-based VPN are supported. In Fortinet, both are supported. Recommended even though like route-based. And why is just, I'm going to explain that also. Fortinet, like both are supported. So depends like on the vendor, whether both type of configuration, policy and route supported or not. Okay, now let's understand from technical perspective. It was about from configuration wise, right? Whether creating tunnel, protecting tunnel with IPsec, and then creating a route in the routing table, or just creating ACL or policy to match the traffic, and then configuring encryption parameters. That's what policy-based VPN is. But from technical angle, technical perspective, there is a big difference, right, between both policy and route-based VPN configuration. Basically, when we set up VPN, so two tunnels are created, right? Two tunnels are created. Two tunnels are created, not one tunnel. One tunnel is for management plane or control plane traffic. So this tunnel, the first tunnel, tunnel 1, also known as phase 1 tunnel. So this IKE phase 1 or phase 1 tunnel is not used for data traffic, right? This tunnel is not for the user traffic, data plane traffic, no. And it's first tunnel or management plane tunnel is bidirectional. So bidirectional means only one tunnel for data sending and receiving. Bidirectional management plane tunnel, phase one tunnel. For data plane tunnel, a separate tunnel, and rather I would say a pair of tunnel is created. Blue color, this one, right? Let me make a space. And it's a I phase two tunnel. Phase two tunnel. And why a pair? Because phase two tunnel is like mainly used for data plane traffic, user traffic, right? And it's unidirectional. So one tunnel for data sending, another tunnel for data receiving. So a pair of phase two tunnels are created. So for user traffic and user traffic, phase two tunnels are used, right? This tunnel for data plane traffic, user traffic, not management plane. So phase one and phase two, there are two tunnels. Phase one tunnel, not for data plane, but phase two tunnel is for the data plane. Now, in policy-based VPN, what happens in policy-based VPN? If there are multiple networks or subnet behind VPN gateway that need to be protected, right? Multiple subnets or networks. So this would increase number of phase two tunnels, right? Means for one network pair, one pair of phase two tunnels are created. Means if like network address here 10.0.0.0, 20.0.0, and here if I take 30 and 40, for example, just only two, not more than that. Just keep it simple, right? So what happens now? I'm talking about phase two tunnels. Phase two, not phase one. Phase one would remain only one tunnel, no problem. Phase one is only one tunnel, but phase two. In phase policy-based VPN, one pair of tunnel will be created between 10 and 30 network. One pair of tunnel, right? Another pair of phase two tunnels between 10 and 40. Second one more zeros, and then another 20 this time with 30 and 20 and 40. So how many tunnels? Four pair tunnels. Four pair phase two tunnels are created, right? In policy-based VPN means number of phase two tunnels increasing with number of subnets or networks that need to be protected. A drawback, right? Even though we have some solution to overcome this problem, and in case if you have used contiguous network subnets rather, then you can do summarization. You can put subnets into a major network to minimize, reduce number of phase two tunnels. We can use some some a NAT or something just to minimize or bring down phase two tunnels to only one pair, irrespective of number of subnets or networks. That is complex and something because root summarization, you understand, if there are completely different networks, then that's not possible. But in case of subnets, contiguous subnets, even we can use that. But literally, this is one of the major drawback of policy-based VPN. And also, above all, dynamic routing is not supported. You cannot use any routing protocol. Only static routing is supported. Whereas if we replace policy-based VPN with route-based VPN, the latest way of configuring VPN, route-based VPN. So it's not only about the configuration, it's also about the bringing down number of phase two tunnels to only one pair irrespective of number of networks or subnets. So phase 2 tunnels would remain only one pair, only one pair of phase 2 tunnels. Even though if there are 10 networks behind R1, there are 20 subnets behind R2, they all need to be protected. Still, only one pair of phase 2 tunnels, right? In route-based VPN. Because we don't create like different ACL or proxy ACL. No, proxy ACL is not required. Plus, we can use OSPF for any routing protocol to route or for routing, because if there are multiple subnets or networks, so probably we would not prefer doing static routing. We'd go with dynamic routing, OSPF maybe. So we can use dynamic routing or routing protocol for routing purpose also. So what we can conclude now, in IPsec site-to-site VPN, there are two different ways to configure VPN policy and route based. If there is choice, then we should always prefer going with route based VPN. And here comes the last discussion of today's session, and that is, what if at one side I have Cisco ASA firewall, maybe, and the other side maybe a firewall like, let's say, Palo Alto, because generally Palo Alto means only route-based VPN, route-based. ASA means policy-based VPN. So now what happens? Policy, and this one is route-based. So now will like this IPsec tunnel configuration communication be possible or not? Because in tunnel negotiation, like route or policy-based VPN is not like matched, not configured anywhere. It's not part of any phase 1 or phase 2 packet, whether you are using route or policy based. No, not like in fact exchange anywhere. But problem here is even though like it's not part of phase 1 or phase 2 negotiation or any packets, but route-based VPN is configured differently than the policy-based VPN, because in route-based VPN we do not mention like when encryption would be done. Like like the proxy ACL, in technical term we use a term proxy ACL. So proxy ACL means like specifying that if source network is 10, destination is 20, then perform encryption or something, or put that traffic inside the tunnel. That's what proxy ACL is. So generally in route-based VPN, we do not configure. In policy-based VPN, yes, we create access list, like access list 101 permit IP this, right? Source and destination. We match that ACL in VPN configuration. That's what policy-based VPN is. But still, there is no problem. Even one end is configured is route-based VPN, policy-based VPN. So in most of the firewalls, in most of the VPN gateways, even though like in Palo Alto basically is a route-based VPN, but still there is one option there to mention to specify proxy IDs. So whenever we set up IPsec tunnel with a device that basically supports only policy-based VPN, so what we do, like even though route-based VPN is configured, routing is done, tunnel is created, tunnel is protected, route is created, but on top of that, we also specify proxy IDs so that communication would be possible, right? So it's not like that both ends should be configured either with the route or policy-based VPN. So you can do this as well, because IPsec itself is an open standard, so it's not proprietorship based. So whenever we create tunnel or IPsec configuration between two different vendor appliances, so can be a bit difficult, tricky, but configuration is like, yes, allowed. Even we do set up IPsec VPN between different vendor VPN gateways. One end Cisco router, another vendor end maybe Palo Alto checkpoint or Fortinet. No problem whatsoever. We can easily set up, but we would have to understand the default settings, default configuration of that vendor, right? Because if I take another example here, and probably in next class I will explain in detail, but in Palo Alto by default PFS, like perfect forward secrecy, is enabled. in Palo Alto. Whereas in ESA, in Checkpoint, in Cisco routers, even I think in FortiGate also, PFS is by default disabled. And PFS is something like computing keys during phase 2 tunnel setup also. PFS is something like keys are computed again in phase 2. And if PFS is disabled, then keys are computed, or this Diffie-Hellman algorithm runs only in phase 1 negotiation, not in phase 2 negotiation. But the question here, if one end has PFS enabled by default and another end PFS disabled, right? So this phase 2 tunnel negotiation will never be successful. You would end up in like only one tunnel, that is phase 1 tunnel. And as I said before, phase 1 tunnel is not meant to be for data traffic, user traffic. No, it's only for like the devices. They exchange like some information. For that purpose, phase 1 tunnel is used, not for the data plane traffic, not for the user traffic. So if there is no phase 2 tunnel, no data plane traffic is allowed to like be routed. So that's where like we would have to be careful whenever we set up IPsec tunnel in between same vendor devices. Very easy to configure. Setting up VPN tunnel with different vendor VPN gateway can be tricky, can be difficult because of default configuration, right? Like phase 1 and phase 2 parameters. So we will have to check each and everything. We'll have to verify whether like parameters, attributes are matching or not. And but if we understand the theory, the concept, logic behind IPsec, so literally it's not a like a very complex configuration VPN. Like, but yes, a lot of troubleshooting is involved in VPN. In fact, because in production network, like in traditional way of VPN configuration, yes, a bit difficult. But nowadays, as you must have seen in even Cisco SD-WAN, like Viptela, uh, IPsec tunnel is created automatically. Keys, crypto keys are automatically like uh, shared by your what do you call it? vSmart, your control plane controller in Cisco SD-WAN. So as such, we don't do any configuration there, particularly for this IPsec, right? What we configure maybe routing or OMP or some other initial configuration, interface IPs, policies, but we never like do anything related with IPsec configuration. But in most of the SD-WAN solutions, internet is used as a transport, even though SD-WAN is not about is not transport dependent solution. SD-WAN is transport independent solution. So what transport has been used in underlay network is not really important. But in most of the implementation, you will find internet as the transport, internet transport, right? Even though like you can use 4G, 5G, LTE, internet, MPLS, any transport, because SD-WAN is transport independent solution. But since internet is commonly used as a transport, so security here again a big task in fact, right? Different size, different locations, SD-WAN solution. So there should be secure communication. Secure communication. For that security, data plane tunnel or IPsec tunnel is created. But do we have to perform any configuration? No, not exactly, right? It's all done in very automated fashion. We just do like policy, we do some other configuration, but not exactly IPsec. But behind the scene, this IPsec tunnel is created. And then like some protocol like BFD like runs inside it. But basically IPsec tunnel is created. So IPsec is widely used. And why now all of a sudden like so much IPsec or SD-WAN like just for last 4 to 5 years? Because like in earlier days, internet means like non-reliable connection, slow data transfer rate, not higher bandwidth. After last 5 or 6 years, now there have been like a paradigm shift. I mean, like internet is fast, reliable, and easily available everywhere, and very high data transfer rate. We can have internet in Gbps also, right? So because of that, even like SD-WAN has become so popular, because this is one of the reason. I mean, like not only the reason, because there are some other benefits also, be that controller base or centralized management and other stuff, or application visibility. There are too many benefits, but one of the big benefit is like using internet as the transport, and internet is now reliable, internet is fast now. So for last 5 to 6 years, like SD-WAN so popular, every organizations is just heading towards SD-WAN implementation, SD-WAN solution, even small customers. And there are a lot of vendors like providing SD-WAN solution. It's not only about Silver Peak, Versa, or Below Cloud. Even as Cisco was not in the race in SD-WAN, so big company like Versa, Silver Peak, Velo Cloud from VMware, and Viptela, of course, not Cisco Viptela, only Viptela. And now you see like this Viptela, of course, has become Cisco Viptela, but also you see like Fortinet, Palo Alto, Aruba. I mean, like all vendors are providing like SD-WAN solution, not maybe perfect SD-WAN solution, but yes, maybe 1, 2, 3, or 4 features of SD-WAN, but they are selling their products, advertising that yes, very much like we provide SD-WAN solutions, we have SD-WAN enabled devices, SD-WAN controllers or something. So too many vendors nowadays, right, in market. But the basic concept is same. I mean, like using internet as a transport, IPsec tunnel is created. How that tunnel is created, do we have to configure or created automatically? Again, depends like on the vendor solution. I mean, like which vendor solution we have deployed in our environment. But IPsec really is very great and secure, but drawback or limitation. So one of the drawback in SD-WAN, sorry, in IPsec, we are not understanding SD-WAN, IPsec is if like data is encrypted, data integrity check is done to ensure like data is not tampered during transport, algorithm runs, data is encrypted. So definitely this IPsec will slow down performance of VPN devices, will increase CPU uses, right? Because each packet is converted from plain text to ciphertext by the sender. Receiver does opposite of it. Receiver performs decryption. Data is decrypted. Very much like CPU is involved in this. If there is no dedicated co-processor or processor to carry out these operations, there is only one main processor, definitely would badly impact performance of your device. First problem. Problem number two, as I said, data is not only encrypted, encapsulated too, right? Encapsulated means extra headers and trailers are added to the original packet. Original packet is this, and then extra header and extra tailors are added, like ESP header, new IP header, ESP tailor, ESP authentication. So this would result in like bigger packet size, bigger packet size, approximately 70 to 80 bytes extra added to the packet, approximately, right? Now, if interface MTU is 1500 bytes, and when encapsulation is done, extra headers and trailers are added to the original packet. So definitely packet size would get increased, right? Maybe 28 or 30 bytes extra, or 72 or 72 or maybe 80 bytes extra. There are some variation in fact. let's say now packet size 1578 bytes, for example, right? Or 1580. So what happens now? Fragmentation is done, right? In order to match with the interface MTU, maximum transmission unit, because MTU means maximum packet size would be 1500 bytes. So what if packet size exceeds MTU 1578 bytes? So fragmentation is done. Packet is chopped off into a small fragments, right? And on other end, fragments are reassembled. Again, this would increase CPU cycle, fragmentation. But we have solution to this problem. We can set the MTU accordingly. We can set the MSS or MTU to avoid fragmentation. So it's another important point to keep in mind, that whenever we are working with IPsec, then at least uh, we cannot change the hardware architecture of the device, right? We would have to plan in advance about the hardware or the appliance that we would be using for IPsec VPN configuration, but at least this MTU, setting up MTU or MSS to avoid fragmentation, yes, can be done anytime by the engineer, by the administrator, whoever is doing like VPN configuration. But these are some, drawbacks of VPN. Otherwise, VPN or IPsec VPN, yes, is a good technology, because if we compare with legacy or maybe P2P lease circuit or any other dedicated circuit or Metro Ethernet or any other circuit. So in that technology, there is always dependency on your service provider, right? Because static provisioning by service provider required. Even when you take MPLS service, so also what happens, like initially, let's say you started with 2 sites only. Now, like third site, third branch site open now. You want to connect with third location, right? So you'll have to ask your service provider, your MPLS service provider, to do some static provisioning, maybe like some configuration, static provisioning, and not maybe, definitely would be required. So this service provider engineer will do like a lot of configuration at their end, right? First. So in like even in MPLS or other technology, static provisioning is required by service provider at first place. Second, internet is available everywhere. And in IPsec VPN, even not necessarily you should have dedicated lease line internet circuit. No, even you can use broadband internet connection, no problem whatsoever, right? Broadband internet connection even you can use, easily available, everywhere available. What about P2P lease circuit or any other lease circuit? It's always subjected to the feasibility. Your telecommunication or service provider, right, may not have like feasibility to the location where your office is situated. So what would happen then? Let's say you have asked your service provider that I need 1 gig P2P circuit between location A and location B. And if service provider doesn't have any POP nearby, there is no feasibility. So maybe like service provider can deny to give any lease circuit to that specific location, remote site, or maybe can ask for like 30 days, 45 days for doing provisioning and all that, right? So there is always some factors like that decide whether you can have leased circuit or not. In case if like location is very remote, not any metro city, but what about IPsec site-to-site VPN using internet as a transport? Easily available, everywhere available, and do we have to ask service provider, internet provider, before setting up IPsec tunnel? No, because nowadays service provider routers, internet routers, they do not block any traffic. In earlier days, maybe 15 to 20 years back, generally like service providers at that time like used to block a lot of like protocols, right? Not to the internet, like were not allowed. So But nowadays, service providers, as per government instructions, maximum what they do, they block certain websites or URLs only, and only on the if like service providers get any intimation or instruction from government agencies, telecommunication agencies, then only URLs or certain URLs are blocked only. That's it. Only URLs are blocked. Web filters are in place still, right? But no other like filter would be in place. That means protocols used in IPsec all allowed by service provider devices, be that IKE, ESP, they all are allowed. So literally, you don't have to ask your internet service provider before setting up internet. So if you have three different sites, four different sites, you want to set up IPsec tunnel, just configure at your own. No need to ask anyone, right? If there is internet, reliable internet connection, you can set up IPsec. So IPsec, yes, is widely used nowadays. Free, not free, easy to configure. Static provisioning by service provider not required. We can have always available tunnel, like IPsec is known as always available VPN, and also we can have on demand VPN. On demand, I mean your remote access VPN, right? Remote access VPN on demand. So if my shift start 8 a.m. in the morning, I'm working from home, and the only way to get access to corporate resources is after setting up VPN tunnel. Then I would just initiate VPN connection at 8 a.m. in the morning. Right, my shift over after 8 hours, then I would get disconnected by then. So remote access VPN is like on-demand VPN. Site to site is always available VPN. So I hope it's more than enough for today. So 2 months theory. In next class, we'll understand like how keys are negotiated, what all informations are exchanged between both VPN peers or parties, like about encryption method, or different packets. In fact, like packet 1, 2, 3, 4, 5, 6. Because in phase 1, total 6 messages are exchanged. In phase 2, 3 messages. So we'll try to understand like about IKE phase 1 and phase 2 negotiation packets. And once we have done with the theory part, then I will show you like how we can configure VPN between two FortiGate firewalls, or maybe FortiGate and Cisco device. I will try to take one or two examples, not only about Fortinet to Fortinet, also will try to understand like tunnel between Fortinet to different vendor, maybe a Cisco router or Palo Alto or any other appliance, right? So we will do like maybe 2 or 3 labs based on your IPsec VPN in FortiGate particularly. But today discussion was not about Fortinet, right? Very generic general discussion about IPsec VPN, irrespective of the vendor. In Fortinet, how do we configure VPN? Very easy, very simple. Wizard-based next, like template-based configuration we have, or maybe we can do custom configuration. But the easiest configuration is in like this Fortinet, and the complex configuration, particularly route-based VPN, is in Checkpoint. Palo Alto is also like easy configuration, not very complex. So configuration wise, yes, depends like on the vendor configuration wise, but technology wise, theory would remain same no matter like whether it's Fortinet or Palo Alto, because it's all like conceptual. I mean like phase 1, phase 2, IKE, ESP, all that stuff. So any questions so far from anyone? Like, because I would end up today's session here. More than enough theory today, so I'm not going to explain like phase 1 and phase 2 negotiation in today's session. Maybe we'll see that in next. Yes, Derek, you want to ask anything?
Yeah. Yep. Question on this IPsec VPN. Is it always it's a point to point? In other words, it's a spoke to spoke, or can it be meshed?
Depend like it depends on the configuration. We have both like options. If we want to set up tunnel in hub and spoke, like scenario, I mean like topology, then yes, we can have hub and spoke topology. And if you want to set up IPsec tunnel in full mesh topology, then yes, you can create full mesh VPN tunnels also. And best practice is like if you have less number of sites, fewer sites, like maybe up to 5 or 6, then you should always go with full mesh or VPN configuration. But too many sites, 20, 30, 50 locations, so hub and spoke is strongly recommended. Be that your SD-WAN or just IPsec in both, like if 5 to 6 locations, 5 to 6 different sites, then 5 to 6, then you should go with hub and spoke, or sorry, full mesh topology. Full mesh topology, right? Full mesh. But if you have 10, 20, 30 sites, 20 sites, so full mesh, you understand, right?
Yep.
What would happen? This would increase number of tunnels.
Yep.
Because number of tunnels is equal to n minus 1 divided by 2. 20 sites means 20, 90 into 190 tunnels. And now managing 190 tunnels, monitoring 190 tunnels, tracking traffic of 190 tunnels, very, very difficult. So not recommended. Like 20 sites means definitely you should go with hub and spoke topology. But we have both the options, right?
Got it. Yep.
Full mesh
Understand.
and as well as this hub and spoke topology. Or maybe partial mesh even. You can go with the third one, best of both, full and this hub and spoke. So you can create partial mesh, maybe 4 or 5 different sites in full mesh topology connected directly with each other, and the rest of the sites in hub and spoke, or maybe dual hub. Like, because if you doubt that there is only one hub, a VPN router, and too many spokes, and what would happen if the hub VPN gateway goes down, becomes offline? So spoke to spoke reachability gone now. So for that, like even you can have another hub also known as dual hub topology. So in the hub and spoke itself, like there can be more than one hub gateway or hub VPN gateway. So larger sites, so definitely you should go with this hub and spoke topology, not full mesh topology.
Got it.
Okay.
Hey.
All right. So if no further question, then our end of session here. But I hope you must have learned something new today, and at least this policy-based VPN, route-based VPN, and also like why not only encryption, uh, about data integrity, also what exactly data integrity check is, and the wide or high level like definition of VPN. I mean like generic definition, only VPN. So when we do not use the term IPsec or MPLS or something. So if someone asks me like what is VPN, so definitely I would reply like VPN means tunneling technology that extends private networks, right, over any shared network infrastructure. Because VPN not necessarily always means encryption, but if someone asks me like what is IPsec VPN, then definitely I would reply like it's encrypted tunnel, secure tunnel, like there would be encryption. So it depends, like just VPN means very confusing, because a VPN could be any tunneling technology. But specifically, if we say IPsec VPN, MPLS VPN, or SSL VPN, then that is very specific then, like whether there would be encryption or not. Okay. All right, so let me stop recording.